The angular speed of a flywheel is increased from 600 rpm to 1200 rpm in 10 seconds. The number of revolutions completed by the flywheel during this time is. So in this question, rpm defines that revolutions per minute. So here we can see that the revolution per minute should be converted to radian. Why it should be converted? Because as we know, the angular displacement, basically in this question we want to calculate the angular displacement, that is the theta, where we need to calculate the angular velocity omega in radian per second and alpha the angular acceleration in radian per second square. So since in this question it is given in rpm, that is revolution per minute, so first we need to convert it to radian per second. How can we convert it? Let's see. So here the rpm basically the nu and the radian per second is basically omega. The relation between omega and nu is omega equals to 2 pi nu. So and the nu should be in revolution per minute, not second. So if you want to write it, then the initial angular velocity should be 2 pi into nu. So nu is here 600 rpm. So 600, and since it is per minute given, so we need to convert it to second. So 1 minute equals to 10 seconds. Then we should divide it by 60. So omega 1 equals to radian per second. Why we have to convert it? Because it is a standard form and we need to see that the omega should be in radian per second. Again, similarly we can write omega 2 equals to 2 pi means to 1200 by 60 radian per second. So if you calculate, then we will get the value. So 10, so 20 pi radian per second. What we have to calculate? We want to calculate the number of revolution. So I hope you remember about the linear equations, that the linear velocity v square equals to u square plus 2as. So we will use the same formula or equations here, but here only one change, that is the object is not moving in a linearly, the object is moving in angular displacement. So we can write that omega 2 square equals to omega 1 square plus 2 into alpha angular acceleration into theta. So we want to calculate the value of alpha, that is the angular acceleration. As we know, the angular acceleration should be the rate of change of angular velocity. So omega 2 minus omega 1 by t, and the time t is given here as a 10 seconds. Then we can just put the values 40 pi minus 20 pi by 10. So it should be 20 pi by 10, so equals to 2 pi radian per second square. So right now we want to calculate the value of the angular displacement, that is theta. So it should be omega 2 square minus omega 1 square by 2 alpha. So if you put the value, omega 2 square will be 40 pi square minus 20 pi square by 2 into 2 pi. So if we take a common of 20 pi, so it should be 20 pi square into, so it will be 2 square minus 1 square, so basically 4 minus 1 3 by 2 into 2 pi. If you further simplified, then you can write 20 pi into 20 pi into 3 by 2 into 2 pi. So simply just cut pi. So 2 will be 10, 2 will be 10 pi. So that means we have a value of 300 pi. So that means the number of revolution completed by the flywheel. So what we get? We get 300 pi. 300 pi is the total angular displacement. So that means for one complete rotation, again complete rotation, again complete rotation. So by this way, the total 300 pi angular displacement or the revolution done by the flywheel. Now if you want to calculate the number of revolution, then we can simply write that 2 pi is the 2 pi is stand for the angular displacement for a complete rotation. Then if we calculate the number of revolution, we can simply divide it 300 pi by 2 pi, because the total angular displacement is 300 pi. So if I just divide it by one complete rotation, then we will get how many numbers or what are the numbers is there for the number of revolution. Then we can cut pi 2 will be 150. So 150 will be the answer. So that means option number 3 is right. Thank you.